Hi friends, you are welcome to Royal Learning Channel. My name is Oluwatoyin. Today we are going to discuss about naming of alkanes and naming of alkenes. Naming of alkanes and naming of alkenes. In my last video, I explained rules guiding naming of organic compound, that is the IUPAC nomenclature. Then the first step to take in naming organic compound is to select the longest continuous carbon chain. You select the longest continuous carbon chain. Then after that, you name according to the number of carbon atom it contains. You name according to the number of carbon atom it contains. Then after then, you number your root hydrocarbon from the end, which will give you the lowest, to the substituent. You number the root hydrocarbon from the end, which will give you the lowest, to the substituent. Then after that, if you have more than one substituent, you name them alphabetically. So we are going to apply those rules in naming alkanes and naming of alkenes. Let's first look at naming of alkanes. Naming of alkanes, that is the IUPAC nomenclature of alkane. The IUPAC nomenclature of alkane. So the first thing that you need to understand under naming of alkanes is to recognize members of alkane. You must be able to recognize members of what? Members of alkane. Then after that, alkane contain what? Single bond in between what? In between carbon atoms. So we recognize the structure of an alkane by single bond in between their carbon atoms. Then another thing, you must be able to derive the molecular formula of members of alkane. You must be able to derive the molecular formulas of members of alkane. Now, the general formula for alkane is CnH2n plus 2. That is the general formula for alkane. Then you derive members of the molecular formula for members of alkanes from this general formula. Now, all hydrocarbons start with the following prefix. All hydrocarbon start with the following prefix: met, et, prop, but, pent, ex, ept, ot, non, and dec. So these are the prefix for the first 10 members of hydrocarbons. That is, for the 10 members of alkane, alkene, and alkyne. They start with this prefix. Now, to derive name for members of hydrocarbon, once you write this prefix, the next thing to do is to what? To add the name ending. For example, now, alkane, the name alkane ends with what? Ane. So the first member now will be methane. You just add the name ending to this met to give you methane. Then the second member, you add the name ending ane to et. It will give you ethane. The second member is what? Is ethane. Then the third member, prop. You add the name ending ane to prop, will give you propane. Then the fourth member, add ane, will give you butane. Then pentane, hexane, heptane, octane, nonane, and decane. So don't forget that members of what? Members of hydrocarbons start with those what? The prefix. Then after that, to bring out name for members of hydrocarbon, you add their name ending. Then the next thing is to understand that you need to understand is the molecular formula for each members of hydrocarbon. Now you need to understand the molecular formula for members of alkane. Now for members of alkane, these are the members of alkanes. The first member is methane, the second is ethane, the third is propane, butane, pentane is the fifth member, 6 is hexane, 7 is heptane, 8 is octane, 9 is nonane, while 10 is what? Is decane. Now, this is our general formula. So you derive their molecular formula from this general formula. Methane is the first member, number one member. It shows that from this general formula, my n will be 1. My n will be 1. So if I substitute this one into this general formula, so anywhere you see n here, you replace with 1. So for this methane now, what will be our formula now? If our n is 1, C times 1 will give me C. 2 times 1, that is 2. 2 plus 2, that is 4. So the molecular formula for methane will give what? Will be CH4. CH4. Then the second member, which is ethane, my n will be 2 because ethane is the second member. So my n will be 2. Substitute these 2 into this general formula. C times 2 will give me C2. 2 times 2 will give me 4 plus 2, that is 6. So it will give you 2C2H6. For propane, substitute 3 into this general formula. C times 3 will give me C3. 2 times 3 will give me 6 plus 2, that is what? H8. C3H8. Then the fourth member, N will be 4. C times 4 will give me C4. 2 times 4, that's 8 plus 2, that is 5. Then if you don't want to continue using 10, that is 10. Now if you don't want to use your general formula to derive formula for other members, the only thing you need to do is to add CH2, because according to homologous series, it says that each successive member differ in its molecular formula, but by what? By CH2. According to definition of homologous series, I've explained that in my last video. Each successive member of hydrocarbon differ in its molecular formula by CH2. So to derive formula for the next member, which is pentane, if you don't want to use your general formula, just add CH2. If you add CH2, 1 carbon atom to this will give me 5 carbon atom. 2 hydrogen to this 10 will give me 12. So that is the formula for propane. So continue adding CH2 to get what? The next members of what? Of alkane. That is how to derive the molecular formula for members of alkane. To derive the molecular formula for members of alkane. Now, let's move to the structural formula. Let's move to the structural formula. How can we draw the structural formula? How can we draw the structural formula of methane, which is the first member? In organic chemistry, each carbon atom must be surrounded with 4 chemical bonds. Each carbon atom must be surrounded with 4 chemical bonds. And from this molecular formula, how many carbon atoms are we having there? Just only 1. See? And the rule says that each carbon atom, that is 1 carbon atom, must be surrounded with 4 chemical bonds. So we surround this 1 carbon atom with 4 chemical bonds. 1, 2, 3, 4. Now, how many hydrogen atoms from here? 4. So those hydrogen atoms will come in. So this is the structural formula for methane. YCH4 is the molecular formula. This is the structural formula. YCH4 is the molecular formula. Now let's draw the structural formula for ethane. Ethane, the second member. How many carbon atoms are we having? 2. Then the carbon atom will be joined together by chemical bond. Carbon atoms are joined together by chemical bonds. Then each carbon atom must be surrounded with 4 chemical bonds. 1, 2, 3, 4. 1, 2, 3, 4. Now with how many hydrogen atoms? 6. 1, 2, 3, 4, 5, 6. This is the structural formula for what? For ethane. This is the structural formula for ethane. And don't forget that in alkanes, we recognize structural formula of alkane by single bond in between their carbon atoms. We have one bond, one bond in between their what? In between their carbon atoms. So let's look at the structural formula for propane. Structural formula for propane. Structural formula for propane. Propane being the third member. Then with how many carbon atoms? 3 carbon atoms. And those carbon atoms will be joined together by what? By chemical bonds. By chemical bonds. 1, 2, 3. Then each carbon atom must be surrounded with 4 chemical bonds. Each carbon atom must be surrounded with 4 chemical bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now we surround with what? With hydrogen atoms. Then 8 hydrogen atoms from the molecular formula. 1, 2, 3, 4, 5, 6, 7, 8. This is the structural formula for propane. This is the structural formula for propane. So you can follow my steps. So and continue. So you can draw more of the what? Of the structural formula of other members of alkane. Now let's move to naming of alkane. Naming of alkane. Then we are going to look at the structure of an alkane. We are going to look at structure of an alkane with substituents. With substituents. I explained in my last video under IUPAC nomenclature that your substituents can be an atom. Then mostly they are atoms of halogens. Your substituent can be an atom, that is atoms of halogen like chlorine, bromine, fluorine, iodine, and so on and so forth. So then it can be a group of atoms. It can be a group of atoms, but those the group of atoms are mostly functional group. The group of atoms are mostly functional group like OH. OH is an hydroxy group, which is the functional group of what? Of an alkanol. Then the COOH is the carboxy group, which is the functional group of an alkanoic. So they are organic, another member of organic compound on their own. They are under homologous what? Homologous series. They are the family of homologous series. But under this place, or under naming of alkanes, those substituents that we can see are halogens and alkyl group. And alkyl group. Then halogens are what? Are inorganic. Halogens are inorganic substituents, while alkyl group are organic substituents. Then what are those alkyl group? Don't forget that alkyl group are derived as a result of loss of one hydrogen atom from alkane. Alkyl are derived as a result of loss of one hydrogen atom from alkane. Then don't forget that you can still use your prefix, that is met, et, prop. So we have met, the prefix met, the prefix et, then prefix prop, boot, pent, then and so on and so forth, to derive what? Name for members of alkyl. So the only thing to add is to add your what? You add your name ending, which is il, met il, et il, prop il, boot il, pent il, and so on and so forth. So how can we derive the molecular formula for members of alkene? Loss of one hydrogen atom from alkane will give us alkene. If there is loss of one hydrogen atom from this CH4, it will give me CH3. Remove one hydrogen atom from four hydrogen atom here will give me 3. So the molecular formula for Met is what? Is CH3. Is CH3. Although this alkene has its own general formula, you can also use the general formula for alkene to derive molecular formula for alkene. The general formula for alkene is CnH2n plus 1. CnH2n plus 1. So if you use the general formula, you are still going to arrive at CH3. You still arrive at CH3. So Met is the number 1, the first member. So my n will be 1. C times 1 will give me C. 2 times 1 is 2 plus 1, 3. CH3. So you can derive it from this general formula. Then you can derive it from the molecular formula of what? Of alkane. By what? By loss of one hydrogen atom. Then if I want to follow this, the loss of one hydrogen atom from here will give me C2H5. When you remove one hydrogen atom, remove one hydrogen atom from 6 hydrogen atom here will give me C2H5. So the molecular formula for Et is C2H5. So which you can also use your general formula. Et is the second member, number 2. Substitute 2 into this formula. C times 2 will give me C2. 2 times 2, 4 plus 1, 5. So the next one is, let's use our general formula. The third member, that's 3. C times 3 will give me C3. 2 times 3 is 6 plus 1, that's H7. Then you can follow your rules according to homologous series, that which says that each successive member differ in its molecular formula by CH2. So you can just start adding CH2 to get the molecular formula for other members of what? Of alkene. So if I add one carbon atom, will give me C4, then 2 hydrogen atom will give me H9. Add one carbon atom will give me C5, 2 hydrogen atom will give me H11. So and so on and so forth. So you can derive molecular formula for other members of alkene like that. So we are going to name this one in naming of what? Of alkanes, because they are the substituents. Then don't forget that alkene group cannot stand on its own in organic chemistry. They don't stand on their own. They are always what? Substituents. Then I said that your substituent can be an alkene group, then it can be what? An halogens. Members of halogen we have chlorine, Cl. So the chlorine under in organic chemistry, naming of organic chemistry, we sound chloro. Then bromine, we sound bromo. Iodine, we sound iodo. Fluorine, we sound fluoro. And so on and so forth. So we are going to need all this in naming of what? Of alkanes. So let's look at a structure of alkane with substituents. Let's look at this structure. If we are to follow our rule, the first step in naming organic compound, we first select the longest continuous carbon chain. Select the longest continuous carbon chain. So from this side, we have 1, 2, 3, 4. This one chain, then this another chain. 1, 2, 3. So but the longest one is this, so we select this one. 1, 2, 3, 4. So this is our longest continuous carbon chain. After that, the next thing is to name according to the number of carbon atoms it contains. Name according to the number of carbon atom it contains. Let's name according to the number of carbon atom it contains. But before we name our root hydrocarbon, we first name our substituent. You name your substituent before your root hydrocarbon. Your longest continuous carbon chain is your root hydrocarbon. Then whatsoever attached to this longest continuous carbon chain is your substituent. So CH3, which is what? Methyl, is your substituent. So then the next step says that number the carbon atom from the end which will give you the lowest to the substituent. Number the carbon atom from the end which will give you the lowest to the substituent. If I number from my right hand side, 1, 2, 3, 4. My substituent, which is CH3, is on the second carbon atom. But if I number from the left hand side, 1, 2, 3, 4. From the left hand side, my substituent is what? Is on the third carbon atom from the left hand side. And the rule says we should number from the side which will give us the lowest to the substituent. Now the right hand side will give us the lowest because the substituent is on the second carbon atom from my right hand side. So it shows that the best position to name is the right hand side. So you number from the side which will give you the lowest to the substituent, which will give you the lowest to the substituent. So from this side now, 1, 2, my substituent, which is what? Which is methyl. My substituent is methyl. Methyl is on the second carbon atom. So what will you call it now? 2-methyl. 2-methyl. Why? Because this methyl, CH3, is on the second carbon atom. So 2-methyl. Then, since you have named the substituent that attach to this root hydrocarbon, you have only one substituent. The next thing now is to name your root hydrocarbon. 1, 2, 3, 4. The fourth, that would be the fourth member of alkane. The fourth member of alkane. Number 4 member of alkane is what? Is butane. So your root hydrocarbon is what? Is butane. So the name of this structure is 2-methyl butane. 2-methyl butane. So let's look at another structure with more than one substituent. More than one substituent. This is another structure. This time around, we are having two what? Two substituents. But the two are the same. Methyl. Methyl. Then, let's look at the head where we are supposed to what? To number. If I number from this side, 1, 2, 3, 4. Then from this side, 1, 2, 3, 4. Now, let's consider this side. Let's consider this side. 1, 2. The first substituent is on 2, comma. Then the second substituent is on what? Is on 3, 2, 3. But if I number from this side, from the left hand side, this is for the right hand side, 2, 3. Then the left hand side, 1, 2. The first substituent from the left hand side is on the second carbon atom, which is 2, then the second substituent is what? Is on the third carbon atom, 2, 3. So it shows that you can name from both sides. You can name this structure from both sides. So just pick any side that you like. Let's name from the right hand side. So from the right hand side, my first substituent is on the what? On the second carbon atom. So that's 2, since they are the same, I'm going to bring the two of them together. They are the same methyl. So bring them together. So the first one is what? Is on the second carbon atom. That's 2, then the second one is on the third carbon atom, 2, 3. Then how many methyl? We have 2 methyl. 2 means di in chemistry. So that's dimethyl. dimethyl. Then you've named the substituents. You've named all the substituents. So the next thing to name is your root hydrocarbon. 1, 2, 3, 4. Your root hydrocarbon will be the fourth member of alkane, so butane. So this structure is 2,3-dimethyl butane. 2,3-dimethyl butane. So let's look at another structure. Now we are going to look at a structure of alkane with two different substituents, with two different organic substituents. A structure of alkane with two different organic substituents. Don't forget that our alkene are the organic substituents. We are going to look at structure with two different organic substituents. Let's look at this structure. This time around, the first thing, let's select our longest continuous carbon chain. 1, 2, 3, 4, 5. There's another chain. 1, 2, 3. Then 2 carbon atom, that's 4. Then another one. 1, 2, 3, 4, 5. But this one is a straight chain, so the best one to pick is this straight chain. So these are our longest continuous carbon chain. Now we have two different substituents. This C2H5 is what is called ethyl. The first substituent is ethyl. Then the second substituent is methyl. The second substituent is ethyl. When you have more than one substituent, when you have two different substituents, they must be named alphabetically. When you have two different substituents, you name them alphabetically. So since we have two different substituents, so you name them alphabetically. Alphabetically, ethyl will come before methyl. So it shows that you name your ethyl before methyl. Then which side are we supposed to what? To number. From which side are we supposed to number? Now from this side, 1, 2. The first substituent is on the second carbon atom. 3, 4, 5. Then from this side, 1, 2, 3, 4, 5. Then if I name from this side, I want to consider my ethyl in naming, because ethyl will come before what? Before methyl. So my ethyl is on the second carbon atom. But if I consider this side, my ethyl will be on the fourth carbon atom. So it shows that the best side to name is the what? From the right hand side. From the right hand side. So let's name from the right hand side. My substituent is on the number 2 carbon atom, which is ethyl. So ethyl is on the second carbon atom. What will you call it? You call it 2-ethyl. 2-ethyl, then comma. Since they are not the same, you cannot bring them together. So you name this one separately. So this second substituent, which is methyl, is on the fourth carbon atom. So that will be 4-methyl. 4-methyl. So you've named the substituent. The next thing to name is your what? Your root hydrocarbon. 1, 2, 3, 4, 5. That will be the fifth member of alkane. The fifth member of alkane. Then the fifth member of alkane is called what? Pentane. Pentane. So the name of this structure is 2-ethyl 4-methyl pentane. 2-ethyl 4-methyl pentane. So let's look at another structure. Let's look at a structure that contains a mixture of organic and inorganic substituents. Let's look at structure with what? Organic and inorganic substituents. This is another structure. This time around, we are having two different substituents, CH3 and Cl. CH3 is methyl, while Cl is chlorine. Then chlorine will sound chloro. Now, when you have a mixture of organic and inorganic substituents, when you have a mixture of organic and inorganic substituents, you name your inorganic substituents before your organic substituents. When you have a mixture of organic and inorganic substituents, you name your inorganic substituents before your organic substituents. Then chlorine is inorganic. So in naming now, you consider chlorine. So chlorine will come before what? Methyl. Chlorine will come before methyl because the rule says that we name inorganic before organic. So inorganic will come first before organic substituent. Now let's consider our chlorine in naming. If I count from my right hand side, 1, 2, 3, 4, 5. Chlorine will be on the 5th carbon atom. But if I count from my left hand side, 1, 2 is on the 2nd carbon atom. So we consider the left hand side in numbering. 1, 2, 3, 4, 5, 6. So if I number from this right hand side, 1, 2, 3, 4, 5, 6. So from the left hand side now, the first substituent is 2, then the second comma 3. From the right hand side, 1, 2, 3, 4. 1, 2, 3, 4. The first substituent is 4, 5. Then we pick the lowest. The lowest is 2, 3. 2, 3. So we number from the what? We name from the left hand side. So we consider left hand side in naming. So our first substituent, which is chlorine, we name inorganic first. Our chlorine is on the 2nd carbon atom. So therefore we call it 2-chloro because chlorine sound what? Chlorine sound chloro. 2-chloro. Then the second substituent, which is methyl, is on the 3rd carbon atom. That's 3-methyl. 3-methyl. Then you have named all the substituents now. The next thing to name is your root hydrocarbon. You name your root hydrocarbon. 1, 2, 3, 4, 5, 6. Your root hydrocarbon will be the 6th member of alkane. Then the 6th member of alkane is called what? Hexane. So the name of this structure is 2-chloro 3-methyl-hexane. 2-chloro 3-methyl-hexane. Let's take one more example before we move to naming of alkanes. Let's take one more example. This time around, I'm going to use two different inorganic substituents. Two inorganic substituents. So we're having two different inorganic substituents from this structure. Bromine and iodine are what? Are inorganic substituents. So when you have two different inorganic substituents, you name them alphabetically. Now alphabetically, bromine will come before iodine. Then the bromines will sound what? Bromo. While iodine will sound iodo. Then if I consider bromine in naming, bromine will be on the 2nd carbon atom. So 1 to 4 from this end, from the left hand side, 1, 2, 3. Bromine will be on the second carbon atom. So the best position to name this structure is what? Is from the right hand side. 1, 2, 3, 4. So my bromine is on the number 2 carbon atoms, second carbon atom. So what will you call it? 2 bromo. 2 bromo. Why? Bromine is on the second carbon atom. Then your iodine is what? Is on the third carbon atom. Iodine is on the third carbon atom. So what will you call it? 3 iodo. 3 iodo. Then after that, you have named all the substituents there. Then the next thing is to name your root hydrocarbon. You name your root hydrocarbon. 1, 2, 3, 4. So your root hydrocarbon will be the fourth member of what? Of alkane, which is called what? Butane. Butane. So therefore, this structure is 2 bromo 3 iodo butane. 2 bromo 3 iodo butane. So now let's move to the next organic compound, the next hydrocarbon, which is alkenes. Naming of alkenes. Naming of alkenes. Then the alkene, the word alkene, the in there means triple bond. It means triple bond. So alkene has what? It has a single bond and a pi bond in its structure. The single bond is called sigma bond. The single bond from the structure of alkene is called sigma bond. While the double bond is called pi bond. Then we recognize a structure of alkene by what? By double bond in its structure. We recognize alkene by double bond in its structure. So the in from this word alkene means what? It means double bond. The in means what? Double bond. So we recognize a structure of alkene by what? By this double bond. Then alkene has a general formula of CnH2n. It has a general formula of CnH2n. Then, like I said, that all members of hydrocarbon start with prefix. They start with prefix met, et, but, ex, ept, opt, non, and dec. So they start with prefix. Members of alkene also start with the following prefix. They start with the following prefix. Now to derive name for members of alkene, so all you need to do is to add your what? Your name ending. So the name ending for alkene is in. So you add the name ending. Under alkene now, under alkene, the first member will now be add the name ending. The first member will be methine. Methine. But there is nothing like methine under alkene. Nothing like methine under alkene. I'm going to explain that. Go and check my video on alkene. Go and check my video on alkene. You see the reason why we are not having methine under alkene, why methine does not exist under alkene. Now let me just tell you now, the reason why methine does not exist under alkene is that the double bond from alkene must exist in between carbon atoms. Then if you use the general formula to derive the molecular formula for methine, methine will contain just only one carbon atom, and this in, which is the double bond that exists in its structure, must be joined together by 2 carbon atoms. That is why methine does not exist under alkene. So there is nothing like methine under alkene. There is nothing like methine under alkene. So the next one will now be what? ethene, propene, butene, pentene, hexene, ethene, octene, nonene, and decene. So these are the members of what? The first 10 members of alkane. The first 10 members of alkane. Then how can you derive the molecular formula for these members of alkane? Substitute this whole number into this general formula to get their molecular formula. So what will be the molecular formula for hexene now? So your n from this general formula will be 2. Your n will be 2. If your n is 2, so that will be c times 2. C2, then 2 times 2, that's H4. So C2, H4. So the next one, substitute 3 into this general formula. C times 3 will give me C3. 2 times 3 will give me H6. Then the next one, C times 4 will give me C4. 2 times 4 will give me H8. Then the fifth one, C times 5 will give me C5. Then 2 times 5 will give me H10. So you can continue by adding CH2 to get the molecular formula for other members. So if I add one carbon atom to this one, will give me C6. Then 2 hydrogen atom will give me H12. Add one carbon atom will give me C7. 2 hydrogen atom will give me H14, and so on and so forth. Now these are the what? The molecular formula for members of what? Members of alkane. So how can we draw the structural formula for members of alkane? The structural formula for members of alkane, like ethene now. Ethene is having what? 2 carbon atoms. 2 carbon atoms. And the carbon atoms must be joined together by what? Chemical bond. Then don't forget that your in from this ethene means double bond. It means double bond. Then the double bond must exist in between what? In between carbon atoms. It must exist in between carbon atoms. So you put your double bond in between carbon atoms. Then each carbon atom in organic chemistry must be surrounded with 4 chemical bonds. Each carbon atom must be surrounded with 4 chemical bonds. So surround each carbon atoms here with 4 chemical bonds. 1, 2, 3, 4. 1, 2, 3, 4. Then with how many hydrogen atoms from the molecular formula? 4. So bring those what? Hydrogen atoms in. So this is the structural formula for ethene. Ethene. This is the structural formula for ethene. So let's look at the structural formula for the next member, which is called propane. How many carbon atoms from propane? That is 3 carbon atoms. Then the in, which is double bond, must exist in between what? In between carbon atoms. That is in between 2 carbon atoms. So you can put your double bond anywhere, either here or here. Then it is possible for you to have more than more than one double bond. I'm going to give you an example on that. So this is our in now. Then each carbon atom must be surrounded with 4 chemical bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Then with how many hydrogen atoms from the molecular formula? 6. 1, 2, 3, 4, 5, 6. So this is the structural formula for propane. So we can continue like that. Now let's start naming of alkene. Naming of alkene. Then we recognize structure of what? Alkene by what? By double bond. We recognize structure of alkene what? With double bond. There is double bond in its what? In its structure. Now let's take this structure without substituent. We are going to name structure without substituent. Now This is the structure of what? Alkane. We recognize this structure as an alkane because of what? Of this double bond. So it shows that this structure is what? Is an alkane. This is what? The presence of this double bond in its structure. Then under naming of alkane, when you want to name, you consider your double bond, which is your functional group in naming. Consider your functional group in naming. So you name from the end, which will give you the lowest to your functional group, which is your double bond. Name from the end, which will give you the lowest to the functional group, which is your double bond. So if I want to name this structure now, you have to consider your functional group. If I name from this side 1, 2, my double bond is on the what? The second carbon atom. But if I name from this side 1, 2, 3, my double bond attached to the what? To the third carbon atom. And the rule says that you name from the end, which will give you the lowest to the what? To the functional group. Which will give you the lowest to the functional group, because we consider our what? Functional group in naming of especially alkene and alkyne. Alkene and alkyne. So our functional group from alkene is what? Is double bond. So we name from this side 1, 2, 3, 4, 5. Now, there is no substituent from this structure, because this structure contains what? It contains only carbon and hydrogen. So therefore, it is a hydrocarbon. It's a hydrocarbon, so there is no substituent. But we must name the position of this double bond. Despite the fact that there is no substituent in our structure, we have to name the position of this double bond. Now, when we look at this structure, 1, 2, 3, 4, 5, it contains 5 carbon atoms. So it shows that it is the fifth member of what? Of alkene, which is called pentene. Pentene. So we are not just to write that pentene like that. We have to name the position of in. You have to name the position of in. So we call it pent. Then your in, which is double bond. Your double bond is your in. Your in is on the second carbon atom. So we call it pentu-in. Pentu-in. Why? Because this double bond, which is our in, is on the second carbon atom. So the name of this structure is what? Is called pentu-in. Pentu-in. Now let's look at a structure with substituents. Let's look at a structure with substituents. So this time around, we're having substituents from our structure, which is C3H7. Then C3H7 is what? Is propene. Like I said, that alkyl are always what? They are always substituents in organic chemistry. Alkyl cannot stand on its what? On its own. Alkyls don't stand on their own, so they are substituents. So C3H7 is propyl. Is propyl. Then, like I said, that you don't consider substituents in naming alkene. Don't look at your substituent in naming alkene. What you consider in naming alkene is what? Is your functional group. You consider your functional group first. You name from the end, which will give you the lowest to your functional group. Don't consider your substituent. Consider your functional group in naming what? In naming alkane. Now, from this side, 1, 2. My substituent is what? Is on the second carbon atom. My substituent is on the second carbon atom. So if I name from this side 1, 2, 3, my functional group, my functional group will be on the third carbon atom. So the best position to name is from this side. Why? Because my functional group is on the second carbon atom from this side. So the first thing now, after that, then you name your what? Your substituent before you now name your root hydrocarbon. So our substituent, which is propyl, is on the second carbon atom. So what we call it? 2-propyl. 2-propyl. Then you name your root hydrocarbon. 1, 2, 3, 4, 5. Your root hydrocarbon is still the fifth member of what? Alkene. that's pent. Then don't forget that you must name the position of your double bond, which is in. So pent2 in, because your in is on the second carbon atom. Your in is on the second carbon atom. If I change the structure of this, if I change this structure, if I move the what, my double bond to this place, let's see how we are going to name it. It will give us another name entirely. If this double bond, if I move this double bond to this what, to this place, it will give us another name. Let's look at it. Don't forget that each carbon atom must be surrounded with 4 chemical bonds. 1, 2, 3, 4. So this one is complete. So likewise, this one is complete. Now, let's look at this structure now. It will give us another name. What did I do here? I just changed the position of the what? Of the double bond. So the name will never remain the same again. The name can never remain the same. Now, what you will consider here now is your double bond. You don't consider your what? Your substituent. If you want to name, you consider your double bond. You don't consider your, you consider your double bond. You don't consider your substituent. So you name from the end, which will give you the lowest to this what? To this double bond, which is your functional group. Now, if I name from this side, 1, 2, 3. My functional group is on the third carbon atom. That is, my double bond is on the third carbon atom. But if I name from this side, 1, 2, my double bond will be on the second carbon atom. So which means that the right position to name this structure is what? Is from the left hand side. From the left hand side, because my double bond is on the second carbon atom from my left hand side. 1, 2, 3, 4, 5. So what will you call this structure now? What will you call this structure? So you've named from the, you've numbered your root hydrocarbon. So the next thing to name is your what? Your substituent. My substituent now is on the fourth carbon atom. So 4 what? Propyl, because my substituent is propyl. So that will be 4 propyl. 4 propyl. 4 propyl. Then after propyl, then you name your root hydrocarbon. You name your root hydrocarbon. Then we are naming from the left hand side, 1, 2. So my root hydrocarbon is the 5th member, that's pentene. So I'll call it pent. So from this side now, my in is on the second carbon atom. So that's pent2 in. Pent2 in. So let's take another structure with different substituents this time around. Another structure with different substituents. Then, like I said, that it is possible for you to have more than one double bond. It is possible for you to have more than one double bond. It is possible for you to have more than one double bond. So there's one double bond here, there's another double bond here. Now let's fill with hydrogen and substituents. So this is another structure of an alkene. So we recognize this structure by what? By double bond. We know that it belongs to what? Alkene, due to the presence of what? Of double bond. Now, how can we name? From which end are we supposed to name this structure? From which end are we supposed to name this structure? And what we are considering under naming of alkene is what? We are considering what? Double bond. We are considering double bond under naming of alkene. So double bond now, we name from the end, which will give us the lowest to the what? To the double bond. I have one double bond there, there's another double bond here. if I name from this side, 1, 1, 2, 3, 4, 5, 6. From this side, 1, 2, 3, 4, 5, 6. Now, if you consider this side, consider this side, the first double bond is on the first carbon atom. That will be 1 comma. Then the second double bond is on the third carbon atom. That's 1 comma 3. But if you consider the left hand side, 1, 2, 3, the first double bond is on the third carbon atom. That's 3 comma. Then the second double bond is on the fifth carbon atom. That's 3 comma 5. So the lowest is 1 comma 3. So we consider what? The right hand side. So let's consider the right hand side. So we have numbered now. So the next thing is you name our substituent. Is to name our substituent. This one is methyl. Then this one is what? Chloro. That's chlorine. Then chlorine will sound chloro. Chlorine will sound chloro. So now, when we have a mixture of organic and inorganic substituents, the rule says that you name your inorganic before organic. Chlorine is inorganic, so it shows that chlorine, you name chlorine first before you name what? You name methyl, because chlorine is inorganic while methyl is what? Is organic. So we name chlorine first. Then chlorine is on the fourth carbon atom, is on the fourth carbon atom. So that is 4 chloro, comma. Then the second substituent, which is methyl. Methyl is on the second carbon atom. That's 2 methyl. 2 methyl. Then you name your root hydrocarbon. 1, 2, 3, 4, 5, 6. Your root hydrocarbon will be the sixth member of alkane, which is called what? Hexene. But don't forget that we must name the position of ene. We're supposed to call it hexene, but we must name the position of what? Of ene. So let's name the position of ene. This time around, we are having 2 ene. The first ene, which is double bond, is on the first carbon atom. So that's 1 comma. Then the second ene is on the third carbon atom. 1 comma 3. How many ene? That's 2. 2 means what? Diene. So the name of this structure is 4 chloro 2 methyl x13 diene. 4 chloro 2 methyl x13 diene. Now let's take 2 inorganic structure before we put this class to an end. So let's take 2 different organic substituents. 2 different organic substituents. Before we bring this class to an end. Now, this is the last example that we are going to take under this alkane, other naming of alkane. Then we bring this class to an end. So let's look at this structure. What we are considering in naming is what? Is our double bond. So from this side, my double bond is on the first carbon atom. From this side, 1, 2, 3 is on the third carbon atom. So we name from where we have the what? The least. 1, 2, 3, 4. Then we have 2 substituents. This one is what? C2H5 is ethyl, while CH3 is what? Is methyl. So the 2 are organic, but they are not the same. So you name alphabetically. So the first one will be what? The one that will come first is what? Is ethyl. Alphabetically, E will come before M. So my ethyl is on the second carbon atom. That will be 2 methyl. 2 methyl, comma. Then 2 ethyl. Ethyl is on the second carbon atom. That will be 2-ethyl. 2-ethyl. Then methyl is on the third carbon atom. That will be 3-methyl. 3-methyl. Then your root hydrocarbon now, 1, 2, 3, 4, will be the fourth member, number 4 member of alkane, that's butane. But we have to name the position of in. We call it but. Then the in, which is our double bond, is on the first carbon atom, so we call it but1 in. But1 in. So the name of this structure is 2-ethyl, 3-methyl, but1 in. 2-methyl, 2-ethyl, 3-methyl, but1 in. So in my next video, I'm going to explain naming of alkyne, then and naming of alkanol. I will explain naming of alkyne and naming of alkanol. If you enjoy this video, comment, share with your friends, and subscribe to Royal Learning Channel. Royal Learning Channel. If you want to type your Royal Learning Channel, don't create gap. Don't create gap between Royal Learning and Channel. Don't create gap. Subscribe to Royal Learning Channel to enjoy more of what? More of my class. So in the next video, I'm going to explain naming of alkyne and naming of alkanol. See you in my next video. Bye for now.